right, section 3.5 talks about nonlinear systems. So in a system of nonlinear equations, at least one equation is nonlinear. With nonlinear systems, you can have graphs that intersect at 0, 1, or 2 points. So let's say we have our line and parabola. So if we have our line and parabola, here's our parabola, and here's a line. Notice on these ones here, they're not intersecting, so there would be no solution. All right, if we have one that goes up and the line is tangent to it, that means that the line touches it in 1 point. There will be one solution. And then our two solutions would be, again, here's our parabola, and our line goes through it at least twice. So here we would have two solutions. All right, and if you think about it, there's really no possible way to get three solutions with a line and a parabola. All right, same with the parabola, okay? A no solution would be something like this. One's going up, one's going down. They're not intersecting, so there's no solution. Okay, again, we could have one that goes up. We could have one that goes down, and they're just barely touching. So there would be one solution. And finally, if I have a parabola going up, I have a parabola going down. And this one here, there are two solutions. So the solutions are where they touch or they intersect. Okay? So as with linear systems, you can solve these by graphing, substitution, or elimination. So I'm going to do one of each for you. All right, so example 1, solve the system by graphing. All right, now you can plug these in your calculator, right? But I'm just going to kind of show you how we can still do it using our brains. So remember, on this one here, we're going to set them equal to 0. So, and we're going to factor. So remember on this one here, what I told you? Look at this sign. Since it's a coefficient of 1, I know I'm going to have an x and I'm going to have an x. Look at the last sign. If it's positive, look at the next previous sign. If that one's negative, then they both have to be negative, because a negative times a negative is a positive. So if we, and then we're going to ask ourselves, what are factors of 12 that equal negative 8? Well, you would tell me it's negative 6. And negative 2 is equal to 0. So by the zero product property, we can say that x is equal to 6 or x is equal to 2. All right, and from last chapter, we can remember that our axis of symmetry is just going to be the average of the two, so 2 plus 6 divided by 2 is equal to 4. And then if I plug that in, so I can get my vertex, right, our y would be negative 4. So I'm going to plug the 4 into the x minus 2 and the x minus 6. So knowing that, I just told you we have our vertex is there. Our axis of symmetry is x is equal to 4. And two of our points are 6 and 2. And that one's going to go up. Okay, so now we're going to do the same for our line. You know that's a line, all right? So I'm going to set it equal to 0, because at least that will give me my x-intercept. I know my y-intercept is at negative 24, but I don't have that on there, right? So I know that I can go negative 4 minus 24, that's going to equal 0. So we'll get 4x is equal to 24. And then x is going to be 6 when I divide. So I know I'm going to have one right here. Okay. Again, my slope is going to be 4 over 1. So 1, 2, 3, 4 over 1. Looks like I did a pretty good job there because it's only going to touch technically in that one point. My line isn't perfect there. But again, it's only going to touch at that one point of intersection. And I'll circle that in red for you. All right. So again, that point there is 6 and 0. I might as well tell you that one too, because we were putting down our intercepts in the previous chapter. Okay. All right. So then we're going to solve the system by substitution. All right. Excuse me. So look, because that's what it's going to ask you to do. It's going to solve by substitution, solve by graphing, or solve by elimination. So remember, on ones like this, I suggested you call this 1 and 2. All right. So we're going to solve 2 for y. Again, use substitution if there's one where it's a single variable, not squared, but one that we can solve for the one. All right, so I can solve that for y. I can say that is negative 2x plus 7. I could have said 7 minus 2x, same thing. All right, I'm going to plug that into 1. Okay, so wherever I see y in 1, I'm going to replace it with 2x plus 7. And remember, I told you whenever I replace something, a variable by something else, I always put parentheses around it. And on this one here, you can probably see why I do it now, because when I distribute that negative outside the parentheses, and again, that is going to be equal to 5 in this case, I'll get x squared plus 2x. Negative times a negative is a positive, plus 2x. Negative times a positive is a negative, minus 7 is equal to 12. Okay, so then I'll bring this all together. I'll get x squared plus 4x minus 7 is equal to, I'm sorry, that's 5 there. All right. So now I'm going to set it in standard form. Remember, standard form, I'm going to bring that 5 over. So there's where I get my 12 that I was writing too fast for. Okay. So what I just did is I wrote it in standard form. So write in standard form. Okay. And then once it's in standard form, we're going to say, is that factorable? Because remember, I just showed you a list of ways to think. If it's factorable, of course, I want to do that first. So I'll say yes. So again, I'm going to look at this, and I'm going to say I have an x, I have an x. The last one's negative, so automatically one's positive, one's negative. And what are factors of 12? When I add them, give me a positive 4. And you would tell me it's plus 6 minus 2. is equal to 0. Again, by the zero product property, we'll get x is equal to -6 or x is equal to 2. So now you're going to solve for y. By plugging into either equation. So I'm going to assume that I solved number 2 right. So I get y is equal to -2. I'm going to plug in -6. We're going to solve. So that's equals. So on that one there, we'll get y is equal to -2 times -6 is +12 plus 7 is 19. And then if I do the other one, I'll get y is equal to -2 times 2 plus 7, or -4 plus 7 is 3. So again, so our solution, let me change color. Is, again, write it as an ordered pair, -6 and 19, and 2 and 3. Okay. And then finally our last one there, solve the system by elimination. All right, so remember, elimination, you're looking for a variable that looks the same. Excuse me. Hopefully it's going to be the y that's going to go away. And in this case, we can see that is the case. Because one's positive, one's negative. So if I just added these, they'll go away. So I'll get 4x squared minus 4x on the left-hand side. On the right-hand side, I'll get -2. Okay? So let's see here. Can I, looks like I can, well, let's just put it all on one side first. 4x squared minus 4x plus 2 is equal to 0. Remember, I said look and see if you can factor something out. Looks like I can factor out a 2. So that'll give me 2x squared minus 2x plus 1 is equal to 0. And again, if I divide both sides by 2, I'll get that 2x squared, because this 2 and this 2 go away, minus 2x plus 1 is equal to 0. So again, once you get it set up in standard form, you ask yourself, is it factorable? All right. And so remember, what I'm just going to kind of show you the diamond here, or the x. So remember, I'm going to take the first and last term, I'm going to multiply them together. That'll give me 2x squared. I'm going to take the middle term, and I'm going to get 2x. Now kind of look, again, you'd want to put something here. All right. Do you have something that will, when you multiply, will give you 2 positive 2x squared, yet when you multiply, it'll give you negative 2x. And what you should find out, ladies and gentlemen, it's a big emphatic no. So if I can't say no, if I say no, then the only thing I can do is I can use the quadratic formula. So use quadratic formula. Remember, that is x is equal to -2, or negative b, right? Because our a is equal to 2, our b is equal to negative 2, and our c is equal to 1. So I'm just using the formula. So then I'll get negative 2 squared minus 4 times 2 times 1. All of that over 2 times 1. 2 times 2 is equal to 2, not 1, I'm sorry. All right. So if we simplified that, we'll see that we'll get 2 plus or minus the square root of negative 4 over 2. All right. Now, we all know that that would give us an I, right? But they asked us about real solutions. So, since the discriminant is negative, the system has no real solutions. So, on the homework, ladies and gentlemen, if it does give you an I don't think it will, but if it does, then you could have gone ahead and said this would be 1 plus or minus 1I, okay? But since I'm pretty sure it's not, again, if they give you a choice and it's there, yes, use it, but I'm sure they're going to say no real solutions. All right, I'm done. Thank you.